Hello, and welcome to another homework help video. Today we're going to be learning how to do the probability of independent and dependent events. If you remember from last week, we talked about what independent and dependent events are, okay? But as a quick refresher, independent events are events that are independent, of course. It means that one event does not affect another event. And inversely, dependent events are events that are dependent, as in one event affects another event. So with that knowledge, now let's apply that to solve the probability of independent and dependent events. So, this first problem. We flip a coin twice. What is the probability of getting heads and then getting tails? Well, first we should identify, is flipping a coin independent or dependent? So if you flip a coin and it lands on heads, does that change anything about the next coin flip? No, there's still the same chance that it will land on heads or tails. Fantastic. That makes our life a little bit easier for the question. So what is the probability of getting heads and then getting tails? So let me get my pen out here. If we can write the probability is equal to, and now we can start constructing our probability fraction. But what is different this time than as we've done previously is we're going to have more than one probability fraction and we're going to multiply them together. So if you remember, also in previous videos, we learned that probability is the want or desire over the total number of outcomes. So how many, what we want over how many possible there is. So with that, so first we have to go along the question in order. So what is the probability of getting heads? Well, if you flip a coin, you would know that the probability of landing on heads is 1/2. Okay? And since these are independent events, landing on heads does not affect the next round of probability, if you would. So then we go to the second probability fraction. What is the probability after we've gotten heads? What is the probability of getting tails? Again, these are independent events. So it's as if we've just flipped the coin for the first time, right? So the probability is 1/2 again, right? Because we have tails as our want. The total possible number of outcomes is 2 because heads or tails. So then all you do is you either take a calculator or you just do it in your head or on paper and you multiply these two fractions together and you find that the probability is 1/4. Well, and this question wants us to write it as a percentage, and hopefully you know, but if not, you can do it in your calculator, that 1/4 is 25%. So let's put it in and see if we're right. Fantastic, we are. Let me erase this quick. Fantastic. Okay. So you pick a card at random. Okay. Without putting the first card back, you pick a second card at random. What is the probability of picking a 7 and then picking a 5? Okay. Well, hopefully you can tell that this is in fact dependent events because you don't put the first card back. So the results of the first card picking affects the probability of the second card pick, okay? If you had put the 5 card back, they'd be independent events because it wouldn't matter what card you got the first time, the probability would always be the same the second time to draw a 5. So let's construct the probability fractions again. Okay, so our first fraction, what do we want? How many outcomes do we want? Well, we want a 7. That's one outcome. And how many total outcomes? How many total cards possible? How many total outcomes? Well, there are 3. Now, last time, when we had independent events, our total possible outcomes didn't change. And hopefully you can see now that with dependent events, they do change. Okay? So now that we've picked up a 7, that card is no longer there. So now we want to pick up a 5. What is the probability out of these 2 cards? Oops, I circled the 7. Let me change colors here. Out of these 2 cards, what is the probability you'd pick a 5? Well, what is the total possible outcomes? How many possible outcomes? There's 2, right? Because you have a 5 and a 6. And how many do you want? You just want one of those solutions. So, let me go back to red here. Now, you can see that these fractions aren't the same, and that's because we had dependent events, okay? So, just to finish off the problem here, we multiply the top. If you multiply, you get 1, and if you multiply the bottom, you get 6. You get 6, and you get 1/6. Excuse me, pardon me for that mistake. And then it asks to write it as a fraction or a whole number. Well, we don't have a whole number, so we have a fraction. So let's see if 1/6 is correct. And it is. Okay, fantastic. Let's do one more question. And we'll read through it, and then I'd like you to pause the video and attempt the problem on your own. First identify if it's independent or dependent events, and once you have, then try to solve the problem using the methodology we learned from the last 2 problems. Okay? Fantastic. So hopefully you've paused it by now and have solved the problem. If not, that's okay. We're going to go through it anyway. You spin the spinner twice. What is the probability of landing on a 4 and then landing on a 5? Well, hopefully you can tell that the spinner acts kind of like a die, because each time you spin, you have the same chance to land on every spot, and if you land on that spot does not go away. Therefore, these are independent events, spinning it and trying to land on a 4 and subsequently on a 5. Okay? So then what is the probability? Whoops. So what's the probability to land on a 4? Well, looks like there's 3 possible outcomes, and there's only one that's a 4, so it would be 1/3. And we're going to multiply that by the probability to land on a 5. Well, since we didn't take away a spot, there's still 3 possible places to land, and we only want 1, being the 5 this time. And, well, quick and easy, you just multiply across. 1 times 1 is 1, 3 times 3 is 9. Let's see if we are correct. And we are. Fantastic. So for these kind of problems, it's not hard if you just take it slow and first identify whether you have independent events or dependent events. If you can identify that, the rest should be easy. Thanks for watching. See you next time.